So, scientific notation. So, what is it? The thing is that you have to sort of have as some background knowledge is place value. So, this big graphic here up at the top talks about the place value. So, at your decimal point and to the right, that first place is your tenth. So, to the left, or excuse me, to the right, you've got your THSs. And then from the decimal point to the left, that starts with the ones, tens, hundreds, and so on. Okay, so you just got to keep those place values in mind throughout this unit with scientific notation. So, understanding scientific notation. So, what's the point of it all? Okay, what's the point of scientific notation? Okay, the point of it is when we're writing really large or really small numbers. So, and it helps us sort of a shortcut. Okay? So, what I always relate scientific notation to, okay, you text, all right? And you don't always spell out every single word, okay, when you're texting, right? You have groups of words, okay, or groups of letters that you put together to represent a group of words. Okay, just like I had mentioned the other day, we all know what that means, okay, when you see it written out. But there is a certain method that you go about when you're abbreviating a group of words. And what's the method? The first letter of every word, right? There's a method to it. Okay, I guess you guys think that that's humorous, but if you didn't use the first letter of every word, that's not common knowledge. People would not understand what you're writing. Okay? So that's exactly what happens in scientific notation. It's a shortcut, okay, to write really big or really large or really small numbers, and there's a specific way that you have to go about writing it. So it says, a number can be written in scientific notation by expressing it in two parts. Okay? A coefficient, A, where A has to be some number from 1 all the way up to, but not including 10. So in other words, it's got to be a single-digit number. And a power of 10, where the exponent is an integer. So an integer just means it's got to be a positive or negative number, or 0. So positive or negative number, or 0. Those are your integers. So you can't have the exponent be a fraction. That's not going to work in scientific notation. So two parts. A coefficient times, and then some power of 10. Okay, where n has to be your exponent. So now it says, tell whether each number is written correctly in scientific notation. If it is incorrectly written, state the reason why. So it says a horse chestnut has a diameter of about 2 times 10 to the 0 centimeters. So what I'm doing right now is I'm checking. Is my coefficient, okay, which it's 2, is 2 somewhere between 1 and all the way up to, but not including 10? Does 2 fall in that range? No. It does. And then you check the power of 10. So times 10 is 0, an integer. Yeah. So this is written correctly. Neptune is about 4.488 times 10 to the 9th kilometers from the sun. Is that written correctly? Is 4.4888, or 88, I think I said too many 8s, somewhere between 1 but not including 10? Yeah? Is 9 an integer?
No.
Is 9 an integer? Is it a positive or negative number or 0? Yeah. Number 3, The approximate wavelength of an infrared light is 0.01 times 10 to the negative 5. Why are you saying no so quickly? It's below 1. Okay? That coefficient does not fall in that range. It's below 1. Okay? No, because 0.01 is, I like the way you guys said that, okay, is below 1. A football field, excluding zones, is 10 times 10 to the first yards long. Why not?
Because 10 is, it's not supposed to be equal to 10.
It's not supposed to be equal to 10. Up here, it could be equal to 1, but it cannot be equal to 10. So, yes, can it be 9.9999? Yes, that's somewhere between, but not including 10. Okay? The coefficient can't be equal to 10. Okay, so this is no. Okay. Go ahead, flip the page when you're ready. Now I want to write each number in scientific notation. So I want to take that shortcut, and we're going to write these numbers that are in standard form. Okay, this is our standard form, and now I want to put them in scientific notation. So this is where the calculator is going to come in. And you're going to start to see patterns happening. Okay, hopefully you're going to be able to kind of get the gist of what's going on with it. So I've got the number 427 and 7/10, or like we say a lot of times, 427.7. Okay? I want to write that in scientific notation. So we just talked about we have to have a coefficient, which is between 1 and not including 10, times 10 to some integer exponent. So who's got a guess on this one? Where can I put the decimal point so my coefficient falls within that range? 1, but not including 10. Yeah. Okay, so tell me what to write. 4.277. Okay, that's a number between 1 and 10, but not including 10, times 10 to what exponent? Take a guess. To the 0 power. Okay? I heard somebody say to the 0 power. Try it. That's it. So on your calculator, type in that answer that I just wrote down. Does it equal the problem that was given to us? Okay. So 4.277 times 10 raised to the 0 power. Does that equal and look like exactly the problem that was given? No. No. 427.7 is not the same as 4.277. Anna, what do you think? We want to change that exponent to the second power. Let's see. So now type in what we changed, and does that equal the problem that was given to us? So 4.277 times 10 to the second power, that equals the problem that was given to us. Okay? All right. What about number 6? Come on, guys. Let's put our hands up. Where should I place the decimal so I get a coefficient that's somewhere between 1 and 10? Jason. Oh, we're on number 6. Go to the right. Yep. So 7 times 10 to what exponent? What do you think? Is this a really big number or a really small number, this 0.0? Really small. So we think it has to be a negative. What negative number should it be? What do you think? -2? We agree? What do you think then? -3? All right, so go ahead and type that in. -3. So 7 times 10 to the -3, does that equal the problem that was given? 7 times 10 raised to the -3, 0.007 it says on my calculator, and 0.007. Number 7. Where should I place the decimal? Katie. Behind the 5 or in front of the 5? Oops, got too many decimals. So is that coefficient somewhere between 1 and 10? Nope. In front of the 5. Okay. So if I put it there, times 10 to what exponent? Is this number 8,561.562.1? Is it a big number or a small number? Some of you are missing what's going on here today. Okay, we all agreed that this was a small number. Okay, 0.007. 8,561. That's a pretty big number. Okay, it's greater than 1. So should my exponent be positive or negative? Positive. And what should it be? I hear a 4 and I hear a 3. To the 3rd. Test it. Type in that answer as you see it, and does it equal what was given? Yeah. Hopefully you're starting to see a pattern happen with the exponents. Okay? Number 8. Number 8. Where am I placing the decimal? 8.
Let's go like in front of the 6, like all the way over.
In front of the 6 or after the 6? After the 6, okay. 6 times 10 to the what? Oh, wait. To the -2nd power. So, type it in. 6 times 10 to the -2nd, does that check? Let's see. 6 times 10 to the -2nd. Okay, gives us 0.06. Yeah. All right, so write each number in standard form. So now we're going to take, we've got it in scientific, let's go back to standard form. Who thinks they know this one right here? 7.1 times 10 to the 3rd. You just think about 10 to the 3rd. What is that equal to? 10 to the 3rd power means 10 times 10 times 10. Don't use your calculator. What do you get? 1,000, right? So if I take 7.1 and multiply it by 1,000, what am I going to get? 7,100. What if you didn't know that? What if you didn't know that? Type it in your calculator. 7.1 times 10 to the 3rd power, and you've got 7,100. All right. Number 10. 8.12 times 10 to the -3. My exponent is negative. Is my number going to be a small number or a big number? Small number. I've got a negative exponent. Chloe, tell me what to write.
I got 0.00842.
Check it. What's happening here? In this case, we were multiplying 8.12 times, think about what we did with negative exponents last class, or last chapter. This is 1 over 10 to the 3rd power. So essentially, we're dividing by 1,000. That's what's happening on the calculator. Number 11, 9 times 10 to the 4th power. Am I going to get a big number or a small number? Anybody? Big number, because I'm multiplying by 10 to the 4th. So what am I going to get now, Brendan? You said 90,000. Again, type that in. 9 times 10 to the 4th. And hit enter. You should get 90,000. 2.5 times 10 to the negative 2. Big number or small number? Small number. Why? Because what's negative? The exponent's negative. So this is really like 2.5 times 1 over 10 squared. So I'm taking 2.5 and I'm dividing it by 100. That's what the calculator is doing for you. Anna, what do you got? 0.025. Last part. Identify the greater number in each pair. Justify your reasoning. So if I look at 5.6 times 10 to the second and 2.1 times 10 to the third, without even using the calculator, what do you think is the bigger number? Cosmo.
I'll go with the bigger exponent.
The one with the bigger exponent, okay? The one with the bigger exponent. So this has an exponent of 2, this has an exponent of 3. So Cosmo is saying that's the greater one because of the biggest exponent. So type them both into your calculator. Double check. 5.6 times 10 to the second is 560, right? And 2.1 times 10 to the third is what? 2,100, okay? But the quick way is just exactly what Cosmo said. The one with the larger exponent. So now, look at that next example. What are the exponents? They're both negative and they're both what? The same number. So can I look at the exponent to tell me which one's bigger? So what should we look at then? The what? What's that called? What's 3.4 and 1.1 called? The coefficient. So which one has the larger coefficient? 3.4. Okay. So write that down. When the exponents are equal, look at the coefficient. Oops.